So good afternoon. Thank you for giving up some of your time to come and listen to me speak. My name is, as said, my name is Mark Baker. I'm the Openstack product manager at Canonical. Canonical, the company behind Ubuntu. Hopefully everybody knows that. So first of all, my apologies for giving this talk in English. It's better for you that it's in English than my German, for sure. So, but if you have any questions and you wish to come and ask them in German, then I have some German-speaking colleagues here that will happily address them for you. So, so I'm going to take about 45 minutes to talk and hopefully cross fingers demo some things that are running with containers. But before I do, who's already running OpenStack today? Wow, everybody. Okay. Who's also running container technologies? Yes, the very enthusiastic man. Yes, good, good, good. And are you running who's running their containers with OpenStack today? On top of OpenStack, yeah, very few, okay. So just give me a feel for it. So, oh, that's not the slide I was expecting. It will do. So, in fact, I'll ask you a final question. Who's using Ubuntu underneath their cloud? Okay, that's a good set. So often when I ask the question, who's using Ubuntu, right? A lot of people don't know. And this is a really good kind of introduction to Ubuntu is actually everywhere, right, as a technology. And so everywhere from underneath the clouds and the infrastructure that who just put your hands up are running is good. But also across many different types and styles of device. And this is very much part of our strategy, is to be able to connect different parts of infrastructure, different styles of application using common technology. And that common technology, of course, is Ubuntu, the operating system, and actually containers too. So you'll see everywhere, if you've been in Uber or Lyft, all of that on the back end is running on Ubuntu. Likewise, if you're lucky enough to have been in a Tesla motor car, maybe I shouldn't say that in Germany, but the Tesla cars use a lot of Ubuntu inside too, and of course a great many different tablets. Things like Pinterest, Snapchat, Instagram are all running on Ubuntu on the back end. So it's a great way. I can tell my daughter, for example, that when she uses Instagram, she's using Ubuntu, and she doesn't really understand what I'm saying or care, but it gives me some relevance in her life. Likewise, some of the big OpenStack users, you see Walmart, Bloomberg, PayPal are running on top of Ubuntu. And then interestingly, on this side, if we look at some of the other areas, Ubuntu running in the public cloud, huge amounts of Ubuntu running in the public cloud. A lot of those companies like Uber and Lyft and Airbnb and others are running in public cloud, of course. And if you look at how many they're doing, it's about 67,000 instances are launching every hour, right, in a public cloud. Does anyone work for a public cloud provider? No? Yep. Ah, there we are, Mr. Jackson, thank you. So, so yes, we do see a great deal of Ubuntu launching out all over the place, which is very good. So even if you're not deploying Ubuntu in your data center today, the chances are that you will have touched something that's running Ubuntu either directly or on the back end during your working day. So Ubuntu in terms of OpenStack, it's extremely popular. It's good to see that in the audience here. It's almost exact, actually, in terms of the 55% or so of people that are running their OpenStack on Ubuntu. And that continues to change in terms of, we see Ubuntu still leading this survey. This is the Openstack Survey, right? The Openstack Foundation Survey. They do this. They do it every 6 months, but they do a really in-depth survey once a year. And we definitely see, right? If you go back a few years, Ubuntu server was much bigger, and some of the others were smaller. But actually, what we have seen in the last year is how users, OpenStack operators, I should say, have been consolidating onto certain operating systems, whereas before, many of them were running multiple operating systems. And so, but Ubuntu still, say about 52% overall, about 54% of large clouds, and essentially still more than all of the others put together, which is good. So continue to lead in that space. And Canonical as a company and Ubuntu as a technology covers a lot of the OpenStack community, if you like, or the OpenStack sphere. So on the left-hand side there, we see a lot of companies, Rackspace, for example, that uses Ubuntu as a base operating system, and there's their own thing with regard to OpenStack and the tooling that sits on top of that, right? But smart enough to choose a great operating system. And likewise, we see that Wells Fargo, AT&T, Best Buy, eBay, Walmart, a great many people that are using Ubuntu as a base OS and then deploying either their own OpenStack, one that they've built themselves, or a third-party OpenStack from companies like Mirantis or Rackspace or others that sit in that space and do that on Ubuntu. In the middle here, we see people that are using essentially our OpenStack distribution, companies like Bloomberg, Numeracy, the HM government, and others. They're using our OpenStack distribution, and they're manipulating that using things like Puppet or Chef or Ansible or Salt or whatever their thing is. And that's great. We're very happy for them to do that. So we move over. We see people that are running what we call canonical OpenStack, our full OpenStack distribution that includes our tooling, which I'll show you some of in a little while. And then, again, you can see all the companies in that space. So Deutsche Telekom being the most relevant example here. Deutsche Telekom, as you know better than me, is not one company. It's many different companies. And so this is in the core network part, what's called PANET, the core network delivery. So, and then over on this side, on the far right-hand side, there's a lot of companies that now increasingly are looking at managed services. So Canonical is relatively small in this space, but are starting to work with smaller companies that want OpenStack delivered as a fully managed service where we will operate that cloud for them to an agreed SLA. So we're covering a wide range of different services and technologies in the OpenStack space, but we think that's a good thing. So if we look at our strategy around OpenStack, in the beginning, there was legacy enterprise software, right? So everybody in this room has degrees of amounts of legacy enterprise software. And when OpenStack started a few years ago, it was very common at that point to say, well, I'm going to launch my VMs in OpenStack, and that's going to give me a lower cost provision than my enterprise VMware style infrastructure. Because that was very much the kind of cost comparison, right? How much is it going to cost me to do it on OpenStack versus doing it in VMware? And so things have changed though, because certainly in the last 5 years, but most recently the last couple of years, we've seen people moving to public cloud en masse, right? So a lot of people starting to move to public cloud, and that means that the dynamic has changed. The comparison point now is no longer how does OpenStack compare to VMware. The comparison point is how does OpenStack compare to a public cloud, right? Because these guys and Rackspace as well can show you that will show you that they are very good at operating these clouds. You can worry about your workloads running on top, and will offer you a very different model, right, in terms of the economics with it, right? They can deliver that as a lower cost per VM than a typical enterprise will be doing. OpenStack kind of tends to sit now in that middle space. So it's still, for many, an on-premises cloud solution. But its cost comparison point has to be compared to Amazon Web Services, against Microsoft Azure, against Google, against Rackspace, against OVH, against all of those others, right? And that's very much our strategy as Canonical, is how can we deliver an OpenStack that allows you to be able to run it, or us, if you want us to take on the managed service provision, to be able to run it at a point, to operate it at a cost point that is comparable to running and managing your VMs in public cloud. Right. We do see, of course, commonality there, Ubuntu being a common unit across that, and a great many organizations we see now today are wanting to be able to have workloads on premises in public cloud, and indeed move them backwards and forwards between, so commonality there in the form of Ubuntu. And actually, the interesting things that people care about on top, and this is just a selection of them, but whether it's running containerized applications, whether it's doing PaaS, whether we're doing serverless computing with things like Galactic Fog, which are equivalents, if you like, of Amazon Lambda, or DOST as an application platform, container-based application platform on top. Those are the things that people care about. And that's a nice little lead into containers. That was the slide I was mixing before. So let's talk a little about what containers are before I dig into it as what an LXD or LXD container is. So most people, when you talk about containers, think about Docker containers. Who's experienced enough to have worked on Solaris here? So yes. So you will know that containers are not new, right? Right. Containers were back in whenever it was, 2005 or something, or thereabouts, were called maybe 2007. I don't know, but they were called Solaris zones. In fact, probably earlier than that, wasn't it? Sorry, 97, 98. But they were called Solaris zones, right? This whole idea that I can take essentially a Unix file system, carve that up into a rooted environment, give people access to those, and they believe they're running in their own machine. So this was not new, and indeed many operating systems have been doing it for a while. But most people today, when we talk about containers, think about Docker. And Docker is essentially an application container that hosts a single process on a file system, right? And it allows you, when you're creating microservices, applications that comprise of very many different microservices, Docker is a very good way of being able to do that, right? But it's not necessarily right for everything. It's one style of container. It's a process container. What I'll be talking about a little, or certainly for quite a bit during this talk, is something called a machine container, right? And a machine container actually is much more like that Solaris zone that you used to have, right? It's something that looks and feels much like a virtual machine, but actually it's a containerized environment. All of these guys, you'll know, sorry, I gave that away too quickly with the build. All of these people that are very heavily into containers, most of them, in fact, not most of them, all of them are doing so with Ubuntu today. So we just drill into those types of containers. If we took a typical Linux environment, we'll have a host Linux file system. How do I get rid of that? Let's try again. Good. So a typical Linux file system, you'll have the gray box, if you like, representing the server. We'll have those lines representing a number of different processes. We'll have the dot at the bottom representing an IP address or a network interface, some connectivity, some storage in there. So that's a typical physical server that you'll see today, very simply drawn. And if we took our application that's running as a process, as this orange or red one that you can see there at the bottom, that's the thing that actually we care about. In a virtual machine, we actually do very much the same. So we will run that virtual machine on top of the physical environment. It has essentially its own local storage that's allocated as part of that VM. It's got a number of different processes that are running. It's got its own network interface, and of course we run our application in there in the same way. If we look at process containers, and this is Docker, runc, and Rocket types of environment, they'll take a slightly different approach in that you can run very many of those, very, very small, and that's because they essentially are only hosting that single process. Right? I'll show you this in a minute. It's probably easier. A machine container sits somewhere between the two of those, and so it is looking and behaving just like a virtual machine, but it's running a container. And so it comes with the same system-level processes that you expect to see, which I'll show you again in a minute, and that process that you would expect to have as part of your application environment anyway. So, and of course, we can run, the nice thing is we can run multiple of those. So again, just in the, give the analogy the old Solaris way, we can run very many of these because we're not launching a new instance of the operating system every time we launch one, which we may be doing in a virtual machine. So they still have a lot of the density, a lot of the speed benefits that you'd see with a traditional environment. So running those machine containers, we have something called LXD. And LXD we call a hypervisor. Now, strictly speaking, it's not true, right? Again, those who are experienced in the audience will know that hypervisors were defined, I think, back in the late 70s or early 80s by IBM, and they defined or some professor at IBM, I should say, and they define them as type 1 hypervisors, being full para-virtualized environments, and so where VMware and Zen are typical hypervisors, type 1 hypervisors. And then type 2 hypervisors, where we're using hardware-accelerated environments such as VirtualBox or KVM. And that was it. Those were essentially your two options, right? We are saying that actually we've got a type 3 type of hypervisor. This is a container hypervisor, so it's one that will allow you to launch and manipulate and manage machine containers, as if they're VMs, as if it's a type 2 VM, type 2 hypervisor running a VM, but actually it's a full machine container. If I go ahead and show you a demo. So let's check, I still got my network connectivity. So I'm running here on baremetal. This is actually running on Amazon EC2. So you'll see my EC2 console here running there. And I should have, if I would do LXD list, you'll see I have a machine container running, right? And that's very, very simple. If I, what do I want to do? If I LXD exec into, what's that name? I've just entered into that container. Can you see that, by the way? Is that, do I need to go a little near the top and just do that? Hopefully that's better. So I'm running inside this container. If I do PSAF, you'll see, ooh, not so nice. There you are. Number of different processes that are running. And you'll see if I do like that, you'll see that these are the typical things that if I was on my machine, natively I would see. So if I did the same on here, you'll see it's going to be more because there's a lot more stuff running on here. But I see the same thing. So I'll see cron, I see syslog running, I'll see a number of different processes that are running, right? So if I just do that again, so you can see a number of different things. So systemd, cron, rsyslog, etc. All of those things that you as admins know and love, right? So very, very, very familiar environment. It's just that I happen to be running in this containerized environment. If you compare and contrast that with, I will cheat and look in my buffer. Did I do that on the other one? Okay, I'll just type it out then. Docker, and I have to do that. Ubuntu, is that going to work? Boom, boom. Okay, so now I'm inside a Docker container, right? And in that Docker container, if I do the same thing, not very much, right? So all I'm doing is just emphasizing the point very, very simply. These are two different styles of container. One is running essentially nothing, just running bash, because that's all I asked it to run. And the other is running what looks and feels like a full Linux environment, but it's actually a container. If I do this, okay. So there's a very simple benchmarking utility called sysbench, allows me to be able to look at CPU cycles and processes and things like that, performance-wise. So if I run that, so I'm running that on my Amazon machine, and for FYI, next time I'll do this on Rackspace, but FYI, it's a fairly beefy machine, so you'll see that it's, where's all the detail about it? It's running, yes, it's a C3 4X large. It's got, I think, 16 gig of RAM and various other bits and pieces. So it's a reasonable machine. It should come back fairly quickly. And it did. So we'll see the total time executing that was just over 10 seconds, 10.5 seconds. If I go into my go back into my LXD container. Have I got sysbench? Did I install that? I did, yes. So I can do the same sysbench, do the same command but running inside my container, right? 10 seconds is a long time, isn't it? So you'll see it's almost exactly the same time. So it was 10.53 versus 10.52. So within a sort of margin of error, depending on what's going on in the box at any one time. The point I'm making here is that running inside an LXD container is as near as to bare metal performance as you can be, right? So within an acceptable margin of difference that you'll see. If you keep running that test, we'll keep seeing different things anyway. So running a container gives you near bare metal performance. And in the OpenStack world, there's actually a lot of interest in how can I get to near bare metal performance for a given workload, right? There's different approaches, different ways of doing that. Boom, boom, boom. Where am I? Let's get rid of that as well to stop any messages coming up. So we see containers, sort of these machine containers sitting somewhere between a process container and a VM. And they offer a number of benefits. That primary benefit is it's going to give you that speed and also the density that you like with a Docker container, but more of the flexibility. That means you don't have to blow your applications apart and create them as sort of 12-factor microservices, right? So they're much more applicable for running multiple different things in. And one of the things that we're running in is in LXD containers is OpenStack. So if we look at LXD has this API. LXD is the daemon that allows us to be able to run these machine containers. And we can run those on multiple hosts and access them via a common API, right? This is what allows us to be able to look at OpenStack services and deploy them across multiple machines as containers. Via the interfaces, we've got a command line application. That's what I've been doing, other RESTful applications. So it's very API-driven. We actually run it, I'm not doing it in this demo, just for clarity's sake, but we can actually run it on top of ZFS. And ZFS gives us, in fact, can I do that? Can I do that here? Yes, so what I can do, so one of the nice things about an LXD container is I can snapshot it, right? A snapshot and restore. And when I do it on top of ZFS, who knows ZFS or ZFS? Yep. It's pretty much the same people that put their hand up on Solaris Zones, which is good. So ZFS is a very high-performing file system. It's very well respected, and it contains a lot of nice enterprise-style features. So it allows you to be able to run, like, it automatically dedupes data, for example. It allows you to be able to do snapshots, restores very, very quickly, which is exactly what I'm going to do. So I have these two containers running. One I'm not going to mess with. This is the Juju one. The other, which I can play with, is this moving catfish, right? It's just an arbitrary name that's given to it. And so what I can do, you'll see here in the snapshot count, we've got two snapshots of that. If I LXD exec catfish and bash, you'll see, is there anything in that? No, it's all pretty empty. Nothing much running at all. So if let's go and do touch. You see now we have an empty file called DOST, right? All very good. This is my container. That's happily running. We'll see my application called DOST, which is running quite beautifully there. As somebody else can come in, what I'll do, and before I do that, what I'll do is I'll take a snapshot of that. Snapshot. And if I do LXD info that, there we go. I've got several snapshots. So snap 2 would be the most recent one. If I then go and do something silly, LXD exec. So I can DOST, take that away. That's going to cause me some problems, right? So I've deleted that. But what I can do is very simply is LXD restore moving catfish. And what was it? It was snap2, right? And it's been restored. Now, that's a super simple demo, right? Add a file, take a snapshot, delete that file, restore the snapshot, that file is back again, as if by magic, right? Super simple. But this is extremely useful if you start placing your OpenStack services inside containers, because it gives you a very nice way to be able to get them back to a known state very, very quickly. And I'll hopefully show you that in a second. Where are we? So why did I say this is the world's fastest OpenStack? So we use, when we're typically deploying, and I'll show you this in a second, when we're typically deploying, we use something called a hyper-converged architecture. So we deploy our services in containers alongside one another. Not always the case. Different customers want to do them in different ways. But we can deploy that extremely quickly. And let me go ahead and show you that. So I will go, in fact, if you have your laptop, you can do this again in real time. You can follow along. If we go onto Amazon, EC2, let's go and find, it was that one, I think. Figure the instance details, and just add some storage onto that. Let's do that just very easily. Review and launch. Boom, boom, boom. So I'm just launching a single instance in Amazon. Why are you doing this? This is what you're wondering. Because as that comes out, what I'm going to do is install OpenStack into that, all 14 or so different OpenStack services into a single instance on Amazon. I can also do it on my laptop, but it does tend to slow it down somewhat. So, but I'm going to do it in Amazon for you. So you can see it's running a whole set of different containers, and hopefully so you can try it at home when you get there. So we'll just see that instance that's coming up, just initializing. Dun, dun, dun. And grab the IP address whilst we're here. In the true spirit, whilst that's taking a second to come up, true spirit, let me show you one that I've prepared earlier. So this is running on Amazon. This is a full installation of OpenStack, and you'll see that we have running, if I go and have a look at here, in terms of hypervisors. You'll see that I've got this type of LXD hypervisor running, right? So within OpenStack, instead of KVM as a hypervisor, or actually we can do both if you want, but I just don't want here. Instead of within OpenStack, instead of KVM, we have LXD running as a hypervisor. So this means when I launch a new instance, it's going to launch as a container machine, right? A machine container. That's going to give you all of those benefits of speed, for example, that we talked about, and the density as well. So it's not as heavyweight as KVM. So we should be up and running there. Let's go and see that we can get in there. There we go. So this is my Amazon environment. I'm just logged in here. I better do, for good hygiene, just go and update all of my repositories. And what I'm going to do is go ahead and install this application called ConjureUp. Has anyone heard of this or used it? No? Good. Hopefully you will try it today. There we go. So let's get back up to the top. And so I'm going to cut and paste that command there. So this is going to install an application that acts as a front end to a set of different tools that we have that we use to manage and manipulate these environments, which I won't necessarily go into the detail of, but you'll see that we have this. It's a front end, there we go. It's a front end that allows to the number of these tools that will enable us to be able to deploy a full OpenStack environment in a single machine or across multiple machines. In this case, it's going to be a single machine very quickly, very easily using these machine containers. So I'm just going to run this command here called ConjureUp. Cross my fingers. There we go. So there's a number of different things that we can install. So if any of those take your fancy, Kubernetes or Apache Hadoop and others. But I'm going to focus on here, OpenStack with Nova LXD. LXD being the hypervisor with OpenStack that we've integrated with Nova. So we'll go ahead and select that. I'm going to do that on my local host. So it's going to be doing it on this instance that I'm running in Amazon. And you'll see here there's a number of different things that I can do. So I may have to zoom out a little. So you can see that, yes. So the number of different things I could do, if I wanted to, for example, go and configure my SQL database parameters, I can go and do that in here. I'm not going to do that as I will mess it up. But if I want to go and configure, for example, which machine I want to be able to put those on, if I had machines and where I want to assign it close to, if I want to. So place it close to another running service. Again, I'm not going to touch that. I'm just going to accept the defaults because that's what you should do in demos. So I'm going to go ahead and deploy all of these, and it's going to start through going through this process of bootstrap and deploying services. And fingers crossed, it should finish. How long have we got? About half an hour. It should finish within the next half an hour. So meanwhile, let's go back to here. So we have, say, our environment running, an environment built in exactly the same way on Amazon. Built it using ConjureUp. It's deployed all of its systems. And you'll see this represents, on here, if I go and have a look here, this represents a logical view of those OpenStack services. So we've got Ceph, for example, running on a number of these. We've got which is that one, the OpenStack dashboard that's running. Each one of these represents a logical view of those services. Now, where it gets interesting, if I go and look at the machines, you'll see that whilst all of these are running on one machine, which is why we only have one option in this column, if I go and click on one of these, you'll see that each one of the services it's running is running within a container, and it's running in a LXD container. Right? It's very interesting in the OpenStack world how having a containerized control plane has become a thing in the last 12 months. So lots of interest in the operator community about how can they run a containerized control plane. But as you can see from this diagram, or this tool, and this is, by the way, this is called the Juju admin screen, and it's how we deploy and manage a lot of the services on the back end. You'll see that all of the OpenStack services that we've been deploying for about the last 2.5 or so, 3 years or so, have been done in this exact way in containers, right? So in a containerized control plane. I believe Rackspace do the same, right, Kevin? Exactly. So containerized control plane are not a new thing, and a lot of the excitement that you'll see about Collar and Docker and Dockerizing OpenStack services, by all means, check in with it and have a look at it. But numerous companies have been running their OpenStack services containerized for quite a while. And so you can ask yourself, why can we do that? So one, it gives us, that bare metal performance, right? But in a way that is much more portable and transposable. So we can back up and restore them. We can actually live migrate these services between different machines. So if I had different machines, I would be able to move these. I can only destroy them. I can't move them right now because I'm running in a single machine. But if I had multiple machines, I would be able to move them between different resources. Right? So it gives us an awful lot of flexibility. What I can do as well, if I wanted to, is I think, can I do that in this version? No. Is that I can also co-locate them together on individual machines. Because I'm only running on a single machine, I'm a little limited as to what I can do in terms of moving these around. But all of these services are containerized and running today. So if I go ahead and, for example, I want to go and launch a new instance. Oh, I need to go up to my project rather and launch a new instance. You see this, it looks and behaves exactly the same way as you would in any normal OpenStack environment. So an OpenStack KVM environment, if I go ahead and add that. And just go and add some networking. Did I give it a flavor? Let's go medium. So just in the same way we would launch a VM as we would with KVM, it does it in exactly the same way, except we're using this LXD hypervisor. It's spawning it as a machine container. What I really wanted to be able to do was SSH into that and show you that running, but for some reason I've not been able to figure the networking out, so I can't do that, which is unfortunate. But you'll see that that's up and running now, and we'll be able to do all those things again that we know and love, be able to create those snapshots and run with them. In the background here, we've got our installation that's running away. So it's deploying all of those OpenStack services. If I go and have a look at this one, we just got that one. Okay, so it's deploying all of oh, that's because it's on a different server, of course. Let's get back to the thing. Does anyone have any questions in the meantime? Yes, sir. No, so Nova is
could you repeat the question for the video?
Yes, of course. So the question was, can you containerize Nova with KVM? I'm not entirely sure what you mean with that. So essentially, can you run the Nova compute service within a container? Yes. With the KVM driver? Yes, I think so. Because essentially it's just KVM running inside a container that's running, connecting through onto the bare metal. So you could question whether you would want to do that or not, but can you? There's like many things in OpenStack. Can you and should you are very different things, but this is a good question. Any other questions? Yes, sir.
Yeah, about this LXD snapshot feature, must the underlying file system be ZFS?
No, it's just much faster if you do use ZFS.
Oh, okay, thank you.
Yeah. Any other questions? No? So essentially, with LXD as a hypervisor inside our OpenStack environment, it allows us to be able to launch those virtual machines as containers, as full machine containers. That gives us that performance. It gives us the performance benefits. It gives us some density benefits, all right? We're able to run more VMs per physical machine than you can with KVM, right? So much greater density. The other nice aspect of it is, as you remember, we did see the bare metal performance. It gives us the ability, and we can do this via managing the Nova scheduler, is that we can launch something called an exclusive machine container. And this is essentially where we will launch a container machine or a machine container, and we'll launch it on a physical host, and we will expand that container, almost like a balloon, to fill up all of that physical host. Right? And so now, you as a user has the ability to say, okay, I want it's essentially the entirety of a machine, right? And I'm getting near enough bare metal performance out of it, right? within 99.5% or something like that, close to bare metal performance. So essentially, I've got a bare metal driver. And in fact, I've got a bare metal driver that gives me some significant advantages over another way of doing this, an alternate way of doing this, right? Because as a user, you will go into that containerized environment. It means that you don't have root level access to be able to flash the BIOS or do anything weird at a device level, right? So if security is a concern, this is maybe something that you'll want to be able to look into. So just looking at, again, the logical view of the services that we're being deployed. Again, each one of these services is deployed within a container. Each one of those could span one or more physical machines. Sorry, these were some demo notes in case the demo didn't work. But so far, they seem to have worked. And we'll flip back to here. Still running away. Any other questions? As you can tell, I'm running out of content, and I can talk quite happily for a while. Well, I was hoping the demo would finish now, but I'm also conscious I'm finishing quite early. So please, if you do have any questions, or you want me to show you some stuff, I'm quite happy to show it. Yes, sir.
Yeah, I would like to know if there is a way to limit how much memory and CPU is consuming the container.
Good question. So yes, there is a way to do it. And I will have to, yes, it's in
I would like to see it more. That because probably I know that there's ways to do it, but I would like to see it.
You want to see it? Okay. I'm going off the demo track now, so this is not something that I've rehearsed.
At least now you have time.
I know, exactly. Not something I've rehearsed in a while. So it is, let me go and have a look there, yes. LXD config set, that's it. So if I have, go and have a look at my containers, I see, yes, I've got the moving catfish here. So with that, if I do LXD info, I should be able to see most of the information around that. You'll see it's running on ZFS at the back end, which is all good. Anything else that's relevant with that? No. What was the command then to see the right bit of info? There we go. So grep processor, CPU info processor. If I LXC exec. What was that? Okay, so you'll see I've got essentially access to everything on this box, right? Which is this is my laptop, so not very much. But I then can see LXD. Is it config set? Oh, yes, config set. Limits.cpu1. Sorry, was it memory you asked or CPU? I'm going to do CPU anyway. I need to do it here. I think that's it. And if I do the same thing again and see that in there, yeah. So I can limit the amount of memory it has access to. There will be the same way of doing that with memory too. Can't remember if it's mem. Okay, memory. Okay. clearly just killed it then.
Probably you were using more than 1 gig already.
There we go. Okay. When things go bad on a demo, always time to bail at that point. So yes, providing you can use the right command and you use a say number, yes, you can restrict. You can certainly restrict the CPUs that it's having access to. You can restrict the amount of memory it has access to, and network devices and things like that.
And the bandwidth for the network also is possible to limit it?
I don't know, actually. I don't know.
Okay, thank you.
I don't think so, is my gut reaction there. Okay, we'll flip back to see how things are doing on here. Okay, we're getting there. We're getting there. So if I try and come back and summarize, because we're running, in conjunction with Openstack, we're running all of the services, all of the Openstack services themselves within LXD containers. Right? And that gives us the flexibility, it gives us the ability to snapshot, restore, and live migrate them. And it gives us, when we want to re-architect our cloud, it gives us a lot of scope there to be able to do that easily without having to reinstall things. Because we've attached the LXD as a hypervisor into Nova, it gives us then the ability to launch virtual machines, machine containers, within Nova. It gives us that same benefits, that same bare metal performance. It gives us the improved density, and still with the ability to live migrate them between different Nova hosts and different machines if we wish. Right? We can snapshot, say, everything within under a second. So often what we'll do is go and, using Xargs and whatever, a bash script, basically just snapshot the whole of an OpenStack environment, delete it, restore it, and restart it again. And you can do that typically in about three or 4 minutes. And we can say pretty much it. Services migrate in real time. So I don't have the grand title I gave the talk, which was the world's fastest OpenStack. I don't have data to back that up. Right? I can't say that this is the world's fastest OpenStack. But what I can say is that using LXD as a hypervisor in your environment, you are going to get close to bare metal performance. Right? Now, is that the world's fastest OpenStack? No, but it's the fastest OpenStack that you're going to be able to run on your environment, the fastest VMs that you're going to be able to run on your environment, short of using perhaps Ironic as a bare metal system. Right? That comes with lots of other benefits too, but it also comes with lots of other drawbacks. So I'll offer up the floor for any other questions. Hopefully we'll see this finish in time. And otherwise I'm going to give you some, wrong one. Give you some time back. Oh yes, yeah, here we go. So we're just at the end of this installation process. It asks us some very simple questions. Do we want to import some glance images? So it'll import some baseline images, baseline Ubuntu images, I have to say, into Glance, set up SSH. Come on. Oh, it's taking a second to do that. So, there we go. Finish that. Configure the networking and configure Horizon. It'll go ahead and do that, and then it will give us a URL with which we can go and access our Horizon dashboard. As I said, this was the one that I created earlier, so you can see it all up and running quite happily here. And I really do implore you to, if you've got access to a public cloud or access to a machine with 16 gig of RAM, right, that's running Ubuntu, you can do it on a machine with 16 gig of RAM, then give it a go. So you'll be able to launch a full containerized OpenStack in a single machine very quickly and very easily. If there's no other questions? Yes, sir. This is all. So the question was, what kind of license applies to this, right? How is this licensed? This is under GPL I don't know if it's V2 or V3, but a GPL license, essentially. So it's all freely available. Go to, I'll show you that website again, if I can find it. conjure-up.io, and it talks about how you go ahead and install it on Ubuntu. It's all GPL software. It's all freely available, non-licensed.
And not limit with the machines, because I got the feeling that's similar to the old autopilot.
Correct.
But autopilot did have some.
Yeah, so
limitation.
Autopilot had a limit of 10 machines, at which point you would have to contact us and then pay for that. But with that, Autopilot also came with bundled support, so the ability to call somebody or pick up the phone, which is why we had to charge for that. So this, if and when it breaks, you get to keep all the pieces, right? So it's freely available, but it's unsupported. Although, if you wish to have support, please come and talk to us, because we'll talk to our colleagues down here, as they'd love to help you with that. But it's it's all freely available. Download it. Please do try it out. Any other questions? No? In that case, I'll say thank you very much for your patience. My apologies, I finished a little earlier than planned. Oh, then this has finished, which is good. So we go ahead and there we go. Finished our install. There's nothing else. Thank you very much.